Percentage part 1 is my introduction to percentages, or percentage, or percent. This involves a lot of explanation, and it also has some questions for you to answer. Now, there are 45 of them. Most of them you'll answer in your head very quickly, so even though it sounds like that's a lot of work, it's not that much. Some of them literally you'll answer in a second in your head. So what does the word percentage mean? And why do we have it? What's the point of it? Why do we introduce something that doesn't have any reason? Well, there's a huge reason behind it, and possibly the best way to explain it to you is, let's say Anna writes a quiz. She does a quiz, and the quiz is out of 25. And she gets 20 correct. Alex writes a quiz as well, does a quiz. There are 20 questions, and she gets 17 questions correct. Who's performed better? It's difficult to say because Anna got more questions correct, but there were more questions in the test. Now, we use the idea of equivalence. I have a video called Understanding Equivalence, or Understanding Equivalent Fractions. It might help you to watch that before you watch this. You may have watched it already, or if you're quite comfortable with equivalence, that's fine. So, percentage simply means how much out of 100. That comes for the word cent. You know the word century is 100 years and so on. So that cent there refers to 100 for every 100. So what we're going to do here is we are going to have a look and say, well, what if Anna had written a test that was out of 100 and Alex had written a test that was out of 100, how would they have scored then? And then we can compare them. So percentages are used to compare things. The first thing we're going to just make sure you get is percentage simply means something, how much you get out of 100. So let's say, remember the old pizza story, have a pizza, cut it into 100 pieces, eat 14. You've eaten 14 out of the 100 pieces, you've eaten 14% of the pizza. This is not going to be a big part of this video, but note that 14 hundredths is also 0.14. There you go. 25 hundredths as a percentage is 25%. 25 out of 100, 25%. 3 out of 100 is simply 3%. 99 out of 100 is 99%. You've eaten very close to the whole pizza, and that's why you often hear people using the expression, 99% of the time. They mean almost always. And some people even say 99.9% of the time. They're trying to make the point that it happens a lot. Some people will tell you, say things like, 99% of all students love iPads. Well, that's an exaggeration. They might not, but it just means a lot. Now, I'm going to use an example here of choosing a quiz team. We've got some students in different classes. Their teachers have given them quizzes, and they're trying to find out who the best quizzes are. Not quizzes as in the quiz, but Q-U-I-Z-Z-E-R. Right, so in Class A, Alice's teacher gives the students a quiz. The quiz has 100 questions. Alice gets 75 questions correct. In Class B, Alex's teacher gives the students a quiz. The quiz has 50 questions. Alex gets 40 questions correct. There's Alice, 75 questions, right? There were 100. She managed to get 75 correct. Alex, 50 questions, managed to get 40 correct. Now, we want to compare who's better at answering quiz questions. Now, I do understand that it depends on what the questions were, and Alex might be better in some things, and Alice might be better in some things. But we need to make a decision. So we're going to sort of try and compare who the best person is at answering quiz questions. And so what I'm going to do is I'm going to pretend that Alex wrote 2 quizzes and got the same score for each. Now, can you see how many questions has Alex answered? Well, there were 50 there, 50 there, so there were 100. And she got 40 correct there and 40 correct there, which means she got a total of 80 questions out of 100 correct. So what have I done? That's why I said it's the whole concept of equivalence. I've changed 40 50ths into 80 100ths. And this explanation, we pretend that she wrote 2 tests, or we multiply by the same number in the numerator and the denominator, which, and I have a video all about understanding equivalence. If you don't understand it, go and watch it. Now, we can see that Alex answers a greater number of questions per every 100 than Alice does. Only a few. And that might not be enough to actually make a big decision. The difference between 75 and 80% is not a huge amount. Right, so there we go. 75 out of 100, 80 out of 100, 75%, 80%. In Class C, Ali's teacher gives the students a quiz. The quiz has 25 questions. Ali gets 19 questions correct. So we'll leave Alice up there, Alex up there. Ali gets 19 questions out of 25 correct. Now, it kind of does mean that you need to recognize that 25 can actually be changed into 100 quite easily by multiplying by 4. So I'm going to pretend that Ali wrote 4 tests. Why? Because that means 25 questions here, 25 questions there, 25 questions there, 25 questions there. Means there are 100 questions. But then I also need to have 4 of these 19s, which when I do, I get 76 out of 100. 19 plus 19, and then you could just double it, or 19 plus 19 plus 19 plus 19, or 19 times 4 gives you 76 hundredths. 76 out of 100 she got correct, which is 76%. So she's kind of between Alice and Alex. 1% better than Alice. Just by the way, in statistics, that's a very small difference. They could write another test and things change, but for the purposes of learning about percentage, this is perfect. In Class D, Anna's teacher gives the students a quiz. The quiz has 20 questions. Anna gets 16 questions correct. Now, we've got Alice, Ali, and Alex at the top. Here's Anna down here. She got 16 out of 20 questions correct. Now, I want to change 16 20ths to a percentage. Why? Because it'll make it very easy for me to compare how good Anna is compared to the other 3 girls. So, I realized that 5 20s give me 100. So I'm going to pretend that Anna has written 5 tests. So it would be 20 plus 20 plus 20 plus 20, which would give me 100. Then I need to go 16 plus 16 plus 16 plus 16 plus 16, or 5 times 16, whichever way you need to do it. And you'll see you'll get 80 out of 100, which means 80%, which means Alex and Anna pretty much performed the same. Okay, so we've got Alice 75%, Ali 76%, Anna and Alex both at 80%. Remember, let's look at what they got in their tests. 75 out of 100, 19 out of 25, 16 out of 20, 40 out of 50. So Anna getting 16 questions out of 20 is a better performance than getting 75 out of 100. And it's also better than getting 19 out of 25. So, simple example there, just trying to explain to you how we use percentages. Right. Now's the time to think about whether you understood all of that explanation. If you're not totally confident, I suggest you go back and watch it before you go any further. We're going to check our understanding, and we're going to write fractions as percentages. Now, there are two sets here. The first set you should be able to do really quickly without even using pen and paper. But if you do need to, of course, I've got this big pause here in the corner of the screen. Every time you see that, the minute you see pause, if you have to pause, do that. And then when you're ready to check the answer, do that. All right. 26 hundredths. How would we write that as a percentage? And for the last time now, I'm going to say pause if you want to, and then carry on when you're ready. 26%. 4%. 80%. 11%. 1%. 79%. 48%. 125%. Now, if you got confused there and you're thinking, well, you can't get 125 quiz questions right when there are only 100, sometimes percentages don't refer to quizzes, they refer to money. And sometimes when you invest your money, you can end up having more money than you started with. So that's a percentage increase. 100%. 204%. 21%. 0%. Now, before you go on with set B, if you didn't quite get all of those correct, just do a little bit of a rewind and do them again. You need to understand that set A really well. Now, with these, it's a little bit like pretending that this person has written 2 quizzes, right? Okay, pause, and when you're ready, continue. Right, I pretend that there are 2 quizzes that would give me 100 questions. That means double this, 60%. 50%. Double the number of questions at the bottom would give you 100, so double the number she got right at the top would give you 50. 8%. Now, with this one, I can see that 25 plus 25 plus 25 plus 25 would give me 100. So I need to multiply this by 4. If I multiply 12 by 4, I get 48. 48 out of 100 gives me 48%. Multiply by 4 at the bottom to get 100. Multiply by 4 at the top, you get 12 hundredths, or 12 out of 100. And it's 12%. 4%. Multiply by 4 at the top and the bottom. 96%. Multiply by 4 in the denominator, multiply by 4 in the numerator. 20%. 106%. And if you didn't quite get that, you double the number of questions, double the number got right. They got more questions right than were in the test, but remember, sometimes doesn't refer to quizzes, it refers to other things. 50%. Now, this one's slightly different. I need to realize that 20 can be made into 100 by multiplying it by 5. 20 plus 20 plus 20 plus 20 plus 20 will give me 100. So I need to make this 5 times bigger. I need to make the top 5 times bigger, the numerator. That will give me 50 hundredths. An equivalent fraction to 10 twentieths is 50 100ths, which is 50%. 25%. 90%. 5%. 55%. 105%. 45%. 40%. Now, this denominator here, 10, I could easily multiply this by 10 and get 100. So I need to do the same at the top. The numerator, which ends up with 40 100ths. 40 100ths is equivalent to 4 tenths. 40 100ths is 40 out of 100, which is 40%. And I see I have made a mistake there. The answer is actually 10%, not 1%. So that should be 10%. Multiply by 10 here, multiply by 10 at the top. 90%. 50%. 60%. Now, you see that's 200. This person wrote a test out of 200. Well, we don't want to know about tests out of 200. We want to know about tests out of 100. So I'm going to half this. I need to half that. So an equivalent fraction to 120 200ths is 60 100ths, which is 60%. 25%. This might take you a while. 95%. Half that, half that. 5%. 100%. Now, 1 could be anything. 2 halves, 3 quarters, 100 hundredths, 10 tenths, 50 50ths. In other words, it's the whole pizza. It's 100% of the pizza. 200%. 50%. And this is one of those fractions you need to remember off by heart, guys. A half is 50%. You just got to remember it in your brain. Laser etch it there forever. I recognize that if I multiply 4 by 25, I'll get 100. So I need to do the same at the top. I end up with 25 out of 25 hundredths, or when we're talking about percentages, 25 out of 100, which is 25%. This is also one of those fractions you need to remember off by heart. %. Same thing, multiply by 4 in the denominator to get 100, multiply by 4 in the numerator to get 75. 75%, another one of those that you've got to remember off by heart. 3 quarters is 75%. Right, I recognize that if I multiply 5 by 20, I'll get 100. So I do that. And to keep the fraction equivalent, I do the same in the numerator. Multiply by 20 here, multiply by 20 here. I end up with 60 100ths, or 60 out of 100. And that's 60%. Similar thing, end up with 20%. And again, 80%. Now, if you were not 100% confident with those, I suggest you go back and watch whatever section you need to do. Set A should be really easy. There is a problem after this for question 5, which you should not try unless you are really, really confident with the stuff that we've done so far in set B. Now, we're going to be talking about giving money away. Benny gives away $20 to charity. Billy gives away $40 to charity. Who's more generous? Now, many of you might have said straight away, well, Billy is. Look, he's given $40 away. But when we think about how generous someone is, well, what happens if Benny had more money than Billy, or Billy had more money than Benny? What happens if Benny gave away $20 from his $50 that he had, and Billy gives away $40 from the $100 that he has? Can you see that if Billy had $100, he would have given away $20, and another $20, he would have given away $40. So in actual fact, they're equally generous. For $100, Billy gave away $40. For $50, Benny gave away $20. If he had doubled the amount to start with, he would have given away $40. So they both have given away 40%, 40 out of 100. 40 out of 100, 20 out of 50, and another 20 out of 50, 40 out of $100, that's 40%. What would happen if Benny started with 100? Benny would have given $20 from $100, which is 20%. Billy would have given $40 from 100, which is 40%. Now Billy is definitely more generous. What about if Benny gave $20 from his $50 and Billy gave $40 from his $200? Well, let's convert them both and see what would happen if they had $100. If Benny had $100, he would double that. He would give away 20 from one 50, 20 from the other 50. He would give away $40 from 100, which is 40%. Billy would give away $40 from $200. So I'm going to half this, which means he would only give away $20, which is 20%. So in this case, Benny would be giving away 40% of his money. Benny would only be giving away 20%, which means here, even though Benny is giving half the amount of money, he's still more generous than Billy because he gives away 40%, he gives away 20%. Okay, here is the problem. There are 7 people there. There are their names. This is how much pocket money they get. You can see this dude, Charlie, here, he gets quite a lot of money every week. This is pocket money every week. This here shows us how much money these people have donated to charity of their choice. It could be SPCA. It could be any charity you can think of. So Chloe gets $20. She gives away $5. Carter gets $100, gives away $30, and so on. Your job is to figure out who the most generous person is and who the least generous person is. So I want you to order these in order from most generous down to least generous. And hopefully by this point you understand you're going to have to use percentages. Okay, so what I'm going to do, I'm going to suggest you pause the video now and start with each person. Do Chloe first, then do Carter, then do Charlie. Okay, we know that Chloe gives away 5 out of 20. So the fraction that Chloe gives away is 5/20. What percentage is that? And when you're done, press continue and we'll go through the answers. Right, here we go. Chloe gives away $5 out of 20, that's 5/20 or 5/20. If I make an equivalent fraction, multiply by 100 at the bottom and the top, I get 25/100, which gives me 25%. Carter is easy. That's $30 out of 100. That's 30%. Charlie, $40 out of $200. So if I half this to get 100, I need to half that. That is 20%. Chester gives away $13 out of $50. So if Chester had $100, how much would he give away? $26. So $26 out of 100 is 26%. Carol has given $6 out of 25. So now to make this 100, I need to multiply by 4. 25 times 4 would give me 100. So then I need to do the same here. 6 times 4 is 24. Gives me 24%. Craig, he has $10. So I want to see what would happen if he had $100. So I multiply this by 10. It gives me 100. I multiply this by 10, which gives me 35. He gives away 35%. He would give away $35 out of 100. And Clementine, probably the trickiest one of all. It's what you would probably need to do is work out how much Clementine would give for each $50 note she has. So there are three $50 in there. So I divide this into 3 equal pieces. So for each one of those $50, if I divide this into 3 equal pieces, I get 13. So she would give away $13 for every $50, which means $26 for every $100, which is 26%. And if I rearrange them, it looks like this. You see that Craig, who only gave away $3.50, was actually the most generous person. He gave away the greatest percentage of his money. The person who was the least generous was the person who actually had the most money. Charlie had $200 and he gave away $40, which ended up being, sorry, it says $20, and that's 20%, not $20 at the bottom. So, if, again, these videos are designed to be watched again and again. If you didn't quite get that, start wherever you need to start. Think about what you've learned and watch it again if you need to.